Um, Data pipeline plumbing. Before we start, let's give me a little bit of a hands. Who knows what stream processing, CDC, event process, complex event processing, whatever you want to call it is? Oh, okay, that's cool. So we have 50 minutes of silence. That's cool. Or does anyone want to take over? No? No takers? All right, fair enough. All right, so we're talking a little bit about different things. There were certainly some hands that were not up when I asked about that, right? So I think we have to start a little bit early. And when you, who read the abstract? Let's try that first. Okay, so not too many. That's good. That's good because the abstract is not actually 100% accurate. The abstract was created before the slide deck existed. And at that point in time, I was thinking about talking about how we used all those kinds of technologies, all those patterns to implement a system that my startup actually created. The problem is, while I was creating the slide deck, I figured there is so much stuff you actually have to talk about to get everyone up to speed that the actual part I wanted to talk about didn't necessarily make it into the presentation. There is a little bit, and we talk about that, but not as much as I wanted. Somehow the mic doesn't like me. Anyway, there you go. So that's me. I'm Chris. Been here a couple of times already. Last year I talked about things I learned about IoT security, things I probably didn't want to know. But as I said, we had a startup and we implemented something. This year, it's going to be more about the backend side. I've been with a couple of companies, some more known than others. Anyone here ever used Hazelcast? All right, that's good. Instana? No? What? No Instana users? Well, I can understand today. I mean, it's IBM now, but it was good in the past, I promise. Ubisoft? All right. Most people know Ubisoft for their interesting take on copy protection. Let's say it that way. I'm doing developer relations normally. That means I'm actually flying around the world, talking at conferences, telling people about different technologies and why you actually want to use those, why they're helpful, right? But I come from a strong engineering background, so that's all cool. I love fairy tales, especially benchmark fairy tales. My favorite one is graphic cards. We're not doing that today because we all know Intel graphic cards are the fastest anyways, right? That's what everyone knows. Anyway, so that is basically the system we ended up at the point when our startup failed, when we ran out of money. That was the system. There's a couple of pipelines, and you don't have to understand them right away. We'll be coming back to that at the end of the presentation. But there's a couple of different data pipelines in here, just so you see what I'm talking about when I said we did a little bit more complex stuff. But before that, as I said, we have to go slowly, and we're engineers. Who thinks naming things is simple? Nobody. Why is that? I don't understand. Naming things is super simple. Ever named a child? I just brought some terms from the world. Oh, there you go. Some of those come more often. Some of those are less frequently used. Some seem to mean the same thing. Some don't. Some seem to mean the same thing, but mean a total opposite. It's a very confusing world. And my favorite thing is that we come to the same things over and over again, right? Who believed that microservices was a new thing? Something we've never done before and didn't name differently, right? Exactly, and that's the same problem. So to build modern applications, and that is where all this stream stuff comes in, is we need to have 3 different things in our applications. They need to be responsive. I think everyone can agree with that. Nobody wants to wait 10 seconds for a single page to update, except for you're booking a flight on Lufthansa. That's a very common thing. It feels like every single update makes this website just going slower than before. The other thing is it needs to be elastic, right? We need to scale up and down according to the needs, according to the number of requests, according to load. And the last thing is that it needs to be resilient, right? Imagine you're a bank, you want to make a bank transfer. We're luckily not in the US, right? Wire transfer is a thing here, like it is in Germany. But that means the system needs to be resilient. We don't want the bank to go offline. If I want to make a bank transfer right now, I don't want to see a website like, oh, sorry, we're in maintenance. Please come back tomorrow. That's not what it should be, right? And the maintenance can mean a lot of things. It's even worse when you see the unknown error. Anyone ever seen a website telling you, oh, an unknown error happened? Right? That's beautiful. That's the best error message ever. You can only make it a little bit better by saying, please retry, right? So the thing is, elastic and resiliency, or elasticity and resiliency, are a thing that are necessary for responsibility, for responsiveness, right? So we need those two things to make sure that those stuff works, and there's also like a connection between those. The interesting thing, we get two things, and don't take them seriously, we get two things out of the box. Let's start with extensibility. Because we're having a system which is responsive, so we want to have it extensible, and we want to have it maintainable. You remember the diagram of the architecture? Maintainability can mean a lot of different things, right? It doesn't necessarily mean it's easy to maintain. It just means it's maintainable. But that means to get all of that, we can use message-driven patterns. And there's quite a few of those message-driven patterns on how to implement that. The interesting thing is extensibility is really good with message-driven architectures, and we're going to see that. Maintainability, well, as I said, right, stuff gets complicated at some point. So what we need to figure out in terms of like terms, what is the data pipeline? I used it before. We often called it a data pipeline. Other people call it transformer pipeline, whatever. But it normally comes down to you have a source, so something where the data comes from. You have some kind of data processors, transformers, enrichers, whatever, one or more, or zero or more, and then you have a sink. Something where you actually send data into. Could be another database, could be a microservice, could be whatever, right? So a data pipeline always means you have a flow from somewhere in the source, doing something with the data and sending it somewhere. And this doing something with the data could be as much as nothing. Literally just grabbing it from somewhere and sending it somewhere else. The other thing is it often goes hand in hand with something like time series. Time series, like event architectures, right? Events often only make sense when they come in the right order. That means a time series is normally, when you plot it, something like that, right? It always looks like the same. It always has this graph where the x-axis has time, the time relation of the data over time. And there is a couple of things that are very common. Financial transactions, I think, is super simple. Stocks is obvious. IoT metrics, when you measure temperature, the only thing that makes sense is to actually look at the change of the temperature over time. Observability data, CPU metric, it only makes sense if you see the CPU usage or memory usage over time, right? It doesn't make sense to look at a single point in time like, oh yeah, it's 37.6. What does that mean? How long was it 37.6? Was it coming down from like 99% CPU utilization, something like that? Events in general, so most of the time, everything that comes in events is obvious. And logs is something people not necessarily associate with time series because like it's a log message. But when you try to figure out a bug or you look at the system, oftentimes it's not a single log message that gives you all the information, but you look at the change or at the log messages over time, try to look at some previous ones, look at some ones coming after, and you're trying to make sense out of that. So trying to understand how the flow of the application is. So that means logs inherently have some time relation as well. And then there is something which is oftentimes weird, but I think anything invoicing, anything like that, often is a time series as well. A small one, I agree with that. It doesn't have millions of events, but when you think about it, you want to refund an invoice, you can only refund the invoice if it was created before. You want to change the amount of the invoice because you do, or the person told you, hey, I want one more of that specific item. The invoice needs to be created before. So there is some time relation when you change or when you work with invoices. So time series don't need to be this massive thing of like millions and billions of events on a single invoice, on a single time series, which is what people normally consider to be a time series, right? Big data. Because we're just talking about big data, who thinks big data is something you do at work? How many events? Or how many? Okay, how much? All right, I'll get that. Okay, so petabyte or a couple of petabytes data, that is a good use case. Oftentimes when you talk to people like big data, they think in like 50, 100 gigs, 150, 500 gigs, and they're like, yeah, we have this massive amount of data, like 100 events per second. That's not big data. That's far from it. I've been at CERN a couple of months ago, and they certainly talk about big data. When you talk to them, like, oh, we have, who has like 1 billion events per day? They were like, yeah, we can do that. No issues, right? Anyway, so looking at it, you always have this like time relation somehow, right? So the order time. And then there is this other thing, and that is where it really becomes horrible. There is free delivery guarantees for stream processing or for message queues, message brokers. And there was a lot of hands when I asked who has experience with that. So scream at me. What are like the free delivery guarantees? Huh? Okay, exactly once. At most once? At least once. I heard you, but it was the right answer, at most once. So the free things are exactly once. That means I guarantee every message is sent exactly once and is processed exactly once. Beautiful thing, super simple. TCP does that all the time. Did you get my message? Yes, did you get your message? Did you get my request? If you get my message, yes, I did get your request that I got your message, right? You have to go back and forth to make sure, hey, the other side actually processed that thing, so I don't have to send it again. If the process that is trying to process something fails, you have to figure that out and send it to another process for operation, because you want to make sure everything is operated on exactly once. A really interesting thing. At most once, simple thing, it's basically fire and forget. You send it out and you don't care if anything happens or not. That's basically UDP. And at least once is the actual implementation for TCP, where you take the acknowledgement and you try to understand, okay, did the other side actually get that message? Did it work out? Did they process it? I wait for an acknowledgement for some time, and if it doesn't happen, if I don't see the acknowledgement, I'll send the message again, just to be sure, right? So that's at least once. The question is, how long do you wait? How often do you retry? I don't know. It all depends on the implementation and other things. So what I said about exactly once was a little bit of a lie, to be honest, right? So obviously, it doesn't like me. There you go. The simple implementation, simple in air quotes, is to say, okay, I need to understand if the other side actually worked on something and I ignore it. So that's the exactly once implementation. The way you normally implement that is you do an at least once, you wait for an acknowledgement, and if you don't get it, you retry, but with something that has some identifier, right? So every operation, or every single request gets a unique identifier, something that is recognizable and I can understand on the consumer side that I actually already seen that somehow. So in this case, or in this case on the service side, right? So the consumer gets a request and it sends it and it creates some item potency key, a UUID, whatever, something random that is unique, sends it down to the service, and the service looks into the database. Did I actually see that process or that request before? If yes, well, yeah, just get me whatever is in the database, whatever the result of the operation is, and send it back to the client, right? Simple thing. That way you can make sure the processing only happens once because you understand, okay, that thing happened before, I worked on that, so I can just give back the previous result, whatever it was, right? The alternative is you store the item potency key because while you're actually processing, it may happen that the same request comes in again, depending on what read time timer or read time delay happens. Then I perform the request. It should store whatever was the result of the request, and then I send it back, right? So the two things are like, either I already did that before, so I can just return, or I didn't, so I have to do it, and it just works. It looks like exactly once from the operation point of view, but it's implemented in at least once, and that's the typical implementation because exactly once is really hard to implement. Until a couple of years ago, I was 100% sure nobody will ever manage to implement that correctly, and I'm pretty sure most implementations will do that under the hood, and it just looks like exactly once to you. So now we have the problem. You remember I said we love to create terms and we love to reuse terms or not reuse those. And that thing is, the whole stream processing thing is really complicated, right? Is a broker, a message or event broker, the same thing as a message event bus? From my perspective, mostly yes. Most of the time I see somebody like, nah. Because they're not clearly defined. But from my perspective, a broker and a bus is basically the same thing. The broker is more of the implementation, how it actually works. The bus means I can send something through. But generally, it's the same thing. Is a message queue or an event queue the same thing? Not really. Sometimes, yes. About 50% of the time, because you have topics and you have queues, right? So a queue is one specific implementation that guarantees order, whereas a topic is another implementation. So an event queue is just one specific thing. It's really complicated. And apart from that, who's old enough to remember like event service bus, ESBs? Yes. Good memory? Great memory? No, right? So to me, that's actually the worst term of all, because it almost sounds like it, right? So how does that work? And I already kind of hinted at that. There's like two basic implementations. You have topics and you have queues. I think everyone understands what a queue is, right? It's a FIFO, first in, first out, and the order is guaranteed. And that's important, right? Because the order often is very important, at least for a lot of use cases. You remember I said you want to work on invoices? You need to make sure the invoice exists before you try to refund it. So the order of those events is actually really important. Same thing, you're looking at temperature change of a sensor. It only makes sense if the events are operated on in order. With a topic, it may actually happen that things come in out of order, which is probably okay, probably not. A good option or a good example of where it doesn't matter could be something like YouTube, right? The YouTube processing queue for uploaded videos. Does it matter if user 1, 2, 3 is operated on before 4, 5, 6? No, it doesn't, right? So it just has to happen everything, but for other things it is. And then there is, or the way it works is with the publisher subscriber, that's the topic, right? So you see that there's two subscribers. They both subscribe to the same topic, though they see different orders. So even with different subscribers, it is not guaranteed that the order is the same, because a topic is completely free. Especially when you think about the at least once delivery, it may happen that the red one is redelivered, so it comes in at a different location. Does it matter? Probably not, right? But that is something you have to think about when you implement those things. With the consumer and producer, that is the queue. Still, both subscribe to the same queue. They get their own copies, but the order is guaranteed. And I actually see that the example is wrong because that is not the same as that one. Ignore it. It should be the same, totally. At least the order is correct here on that side. And then there is something, and that is where I think you remember the extensibility, maintainability, scalability, resiliency, all that is where subscriber groups or consumer groups come in. And that's a really interesting topic, because now what you do with multiple subscribers, you subscribe to the subscriber group, or you add them to a subscriber group, and the subscriber group connects to the topic, saying, okay, I'm gonna fan that out, right? So you see that while we have 6 input, both of these subscribers only get 3. If I want to process like 1 million objects, I can just start more subscriber instances and get this automatic scalability. Really nice. Sometimes it's a little bit more complicated. I think I don't have an example for that. Especially when you need to make sure that, for example, you have multiple devices and you want to make sure that all the events for a single device are operated on by a single subscriber, then you need to make a little bit more fancy stuff. I recommend using Kafka and partitions, and use partition key or something. And while we were talking about Kafka, there is quite a few different implementations, and the list isn't complete. There is way, way, way more. Kafka is the obvious choice. Who uses Kafka? Who loves Zookeeper? Right? Anyone using Kafka in Raft mode in production by now? Nope. I see some people like, what is that? So Kafka just released a new version, or I think it actually released that version 2 releases ago. Kafka doesn't need Zookeeper anymore. They now have their own standalone Raft implementation. Go for it. Getting rid of Zookeeper is probably the best thing you can ever do. Nuts is a Go implementation. They have topics, they have queues, they have all kinds of stuff. When you want to go for like super low latency, Nuts is really nice. Redis queues are around for quite a while, but it's a queue implementation, so they don't have topics. Obviously, AWS has at least 2. There's probably more things. Azure has Events Hub, or Event Hubs. I think that's how it works. Go has PubSub. PubSub Hubbub, is that still a thing? I don't know. So all of the cloud providers have their own things. I'm not a massive fan of those because they always give you the vendor login, but that is just me, right? They work great. They work fine. And then you have MQTT, and that is interesting. It's a protocol. HiveMQ is just like one of the most common implementations I've seen in enterprises. MQTT is interesting from the fact that it is MQTT protocol is created for millions and millions of topics. When you try to use Kafka with millions of topics or millions of queues, Kafka is not necessarily your friend anymore. It works great with 1,000, 2,000, 5,000. Millions is different. MQTT often comes in when you get down to anything IoT. Connected cars. Every car in a connected car environment often has like 6, 7 topics. There's a command topic, there's an upgrade topic, there is a positional topic, whatever, right? And MQTT is designed for that kind of scale. So if you want to do something like that, MQTT is your friend. There's RabbitMQ, which I think is written in C. There is ActiveMQ, which unfortunately I don't think you can actually make it order guaranteed. If somebody knows how to configure that, please let me know. But there's a lot more. The number of implementations are vast, almost impossible to count. They all have their pros and cons. It's that simple. If you have a use case, really look at the different implementations, try to figure out what is the easiest thing to run at my specific use case. Because Kafka is oftentimes like the obvious answer, right? What kind of message queue or message broker should we use? Kafka. Do you need that? Probably not. So, and that means we're out of like the basic stuff. Now we're all at the same level, right? We're all up to speed. Now, people are like, I don't know, was way too much stuff already. So don't be afraid, there's more coming. CDC, change data capture. Anyone using that? Okay, keep your hand up. Who heard of that? Raise your hand as well. Okay, so that was like 3, 4 or 5 people more. Okay, so CDC is typically something where you have a database and you want to capture the changes, the mutations to your database, right? So you do something in the UI, you have a source database and there's orders, and ignore the outbox for now, we're coming back to that. And you have 2 services. You have some notification service and some invoice service. So what I'm doing is somebody's ordering something on my website, and I want to send a notification like, yes, we received your order, right? Like the typical order confirmation, and I want to generate the invoice and send it out as well. So how do I get from my source database, where I now have all the information about the invoice, to those 2 services? First of all, you make magic. Magic is always good. We love black magic, right? So that's the beautiful thing. You put some event queue, in this case Kafka, and we're done. Awesome. So I think we're good, right? That's how it works. The problem is, how does that magic thing work? And there is a couple of different implementations. Debezium, 2 Debezium users. Wow. Not more. Who knows Debezium at least? Okay. Okay, that's a few more. So the way it works is, and this is a Postgres example. For other databases, it works slightly different, but the concept is generally the same. You have typically like 3 mutating things in SQL. It's an insert, it's a delete, it's an update. Those things change stuff in the database. And the way it works is, it all goes down in Postgres, it's the write-ahead log. In other databases, it's called transactional log or transaction log or whatever. But in general, it's a list of changes, right? So every change in the database goes in, and they obviously have an order, because one change depends on the change before, So in Postgres, it kind of works like that. You have the tables, and you have the query engine. You have something that stores data somehow on the disk, right? That's the storage engine. You have this like transactional thing, this transaction log. However that thing works, we're not talking about Postgres implementations here, and or internals. And you have something which is called the replication engine. The replication engine is specific or special because normally what you do is you use it to implement HA, like read replicas, high availability, failover, stuff like that. So this Postgres instance, as a secondary, will connect to the primary and say, hey, please send me all the changes on specific on specific tables or on specific databases, and I'm going to apply those locally as well. So at least for Postgres, like what Debezium does and all the other CDC tools for Postgres, they do use the same mechanism and say, okay, I have a different tool, which is not Postgres, but it claims to be Postgres, a different Postgres database, and it does a replication connection connecting to the replication engine, saying, hey, I'm a Postgres instance. I want all your changes. And then it does something. It receives all the records. It receives them in order, because order matters. It does some processing, normally transforming those into JSON objects or whatever, right? Could be Avro, could be protobuf. And then it generates the actual event that is going to be sent to the message queue. So that's the magic. That is the magic part. Simple, right? Because magic is always simple. What could possibly go wrong? But CDC only helps you when you do certain things. So CDC can be done in a couple of different ways. Let's say it that way, right? So event sourcing is a way where you do not go to the database, but you try to capture those changes earlier. Basically saying, hey, I have a UI, and everything happening in the UI, everything mutating, is going to send as an event into an event store. Kafka, whatever. Sometimes people use an extra database and use CDC to capture it from the database, sending it to the event store. In this case, we consider the event store being something like a database, that can also replay, right? So it could be Kafka. The interesting thing with replay is that you could actually go ahead and say, hey, I want the state at that point in time, and then please start to send those events again over and over again, because I have a bug and I'm trying to figure out why this stuff happens. It's a really interesting thing. It doesn't mean it's only delivered once. When you have an event store, you have all the change events in the event store, and you can start replaying at every single point in time. I'm not saying use Kafka as your database. That's not a good idea, at least not from my perspective. And you have the event bus, which oftentimes is implemented inside of the event store when we talk about Kafka. And you do something in your data pipeline. You write it to a final database, which is the read database. And when the client tries to show something, it goes down to the database. That means it's completely asynchronous, right? Until you've written it to this database, the UI will not show anything. You can refresh as often as you want. Those things are still useful, right? I said the YouTube example earlier. LinkedIn, anything where you have like a massive number of servers, it can be very interesting to see those things. And yeah?
Do you know of a real-life project that is the event source really got used?
No. No, I don't. At least not from a UI level. I've seen it from a backend level, but I don't consider that event sourcing. We're coming back to that. From a UI perspective, anyone here that uses event sourcing from a UI? No, right? Yeah, I agree. I haven't seen it in real life. Because the problem is, for most use cases, that is an issue. As I said, I've seen it for backend services, but I consider those differently. The other thing I said, we're coming back to the outbox. So the outbox works slightly different. And that is normally, or I would always implement that with CDC. Unfortunately, it's done differently most of the time. You have a request that goes to a REST API. The REST API writes the order. So we're always coming back to the invoice example. But in the same transaction, it also writes into another table, which is called outbox. And the outbox basically is a list of operations that need to be done. The interesting thing is, when you write those two things in a transaction, and something happens before the transaction is finished, it will never appear in the outbox. So you can 100% make sure that nothing happens as long as the operation in the REST API was correct and was successful, right? You can do the same thing. Some of the message queues implement two-factor, not two-factor, what is it? Two-phase commit. Two-phase commit. I prefer that because it's much easier. You only have a single data thing to work on. So now we have the operation, like generate the notification, generate the invoice in the outbox, and you need something to publish it to the actual message queue, so the services will get that events or those requests. The way it normally works, and I really hate that implementation, there is a publishing service that polls the outbox table. And I consider polling against the database a crime. I think it should not be done, right? Just don't do that. Use a CDC tool that replicates any change in the outbox table and send that to the publisher. Add just a slight message queue in between. Yes? Right. Okay, so yeah. Let me see if I understood that correct. So some databases, well, most databases have the option to notify an application. In Postgres, you can actually raise a notification inside of the application when you're listening to that. The problem with those things is they're not transactional. So when you raise the notification, it will raise the notification. If afterwards the transaction fails, you would still have the same issue. You would have the event generated on the queue without the need for it because the operation failed. If I understood you correct. Yes, okay, a trigger on insert would, yes, a trigger on insert, that is a good question. So would a trigger work? I think not, because the trigger would be executed the second you insert, and you would still generate the notification instead of a transaction. Or you would have to do this like trigger after.
The commit was the transaction. I'm 100% sure because we use
Are
this
you?
method all the time, and I wanted to ask this, when we use Debezium, so get down from an application level to, let's say, infrastructure component level, abstracting it away, and then also binding, like you need then basically Debezium to write to Rubrik or write to Kafka, you need the adapters there to be available.
Right.
But if you're in your application, then you have all this stuff because you have to connect to Postgres anyways. You have to connect to
That is an interesting thing. I need to try that. So what he said is, he believes that triggers are executed after the transaction. If that would be true, and I think it's not, but I'd like to try that. That would be that's certainly something to try, because then you could use a trigger and raise a notification in the trigger to basically send this change or the notification that there is something to the application.
I think a USP for CDC, so why is CDC really valuable, is that it operates on the change data, on the change log, not on the database itself. So the application performance will not get impacted by the extraction of the data.
Yes,
I think that's the USP of CDC.
Yeah, that's while it also depends on the implementation. So what he said is the real use case, or one of the real use case for CDC is when you raise notifications with a trigger or something, you will have overhead inside of the application that is acting against the database. Whereas with CDC, because you're acting on the transaction log, so after everything happened in the database, it's a separate process which is completely independent. It runs in the same hardware, but it doesn't run in the same process, which is yeah. All right. To finish that up, the publisher does the same thing, right? It retrieves all the changes, it generates events, it sends them to the event bus. That means a CDC tool like Debezium can actually be the publisher. You don't have to write that service, which is really nice and really interesting. CQRS, the command query responsibility segregation, apart from the word segregation, which I really hate. I think it's the worst English word ever. The way it works is, and that is where I said I come back to the idea of like the event sourcing, but on a backend level, I consider CQRS kind of that thing. So the way it works is you have two different queues. You have a command queue where you send changes to, or change requests to, change commands to, and you have a second queue which is handling all the queries. The way it works afterwards is that you have two different databases. So you store all the raw data in the write database, and you have queries against the read database. And in between, you have something like eventual consistency. It doesn't mean that the data will be the same between those two databases, because normally what happens, you send them to an event bus, which could be a full data pipeline, and that's the reason why it says materialized view. So the way it works is you take the raw information, you enrich it, you work on it, you act on it, and you write down whatever the final result is into the read database, which makes the reads extremely fast, right? Because remember, I brought up the YouTube example. Imagine you uploaded your video. So the command would be, or one of the commands would be, process all the videos. YouTube generates a lot of different versions of different resolutions of the same video, so that could be a command. That goes to the write database. The data pipeline will do the actual processing, recalculating the video in the different resolutions, and then store everything, like all the generated files or all the generated file names, or however that works, in the read database. And when you go to YouTube and say, hey, give me that video, it will go to the read database and have all the information pre-processed and know exactly how it works. From my perspective, that is kind of event sourcing, just on a back-end level, and it works much better. Still, it is completely asynchronous. It does not work for all use cases, right? If you update a profile on LinkedIn and you send it here and you would refresh immediately, you would not see your own changes. So guess what? You're going to do the changes again and again and again. Eventually, you may see the first update, but for anything UI, this is really complicated, at least when the user expects to see changes immediately. But for YouTube videos, it doesn't matter, right? Especially it doesn't matter between different users. If I go to YouTube, I may see the new video already. You don't. Does that matter? No. It doesn't matter for YouTube. It doesn't matter for us. Eventually, everyone will see the same videos. If it works. Sometimes it's a little bit flanky. I have a few things. I have N8N as a workflow engine. Who knows N8N? Nope. Node-RED? Okay, few people. N8N is the better version of Node-RED, a little bit more production ready. The way it works is you basically build your own data flow out of those little icons, some functions, stuff like that. I have a Stripe web listener here running here to actually send a specific, or send the Stripe events. Stripe is a thing, right? Stripe for payments. So I capture Stripe events, send them to one of the workflows. That's not Debezium, that is my CDC tool, which I specifically wrote for timescale. But it doesn't really matter because it behaves the same thing. And for everyone who knows me, I'm a craver for Japanese food and Japan in general. So what I did is I used a low-code platform. Not that I recommend that for anyone. It was not a pleasant experience. But what I did is I created a fake Japanese food delivery service, right? The good things. So the idea is, and you remember the notification service, so that's my phone. And if everything works out, after I order some stuff, I should eventually get like, yes, we received your order, and we also received the money, and we're good. So because I'm German, let's start with a beer and some tonkatsu. And because we're just here, takoyaki. Takoyaki is octopus balls. Really nice. Fried octopus balls. All right, so let's see. Unfortunately, you can't. Let me see if I go to executions. We should maybe see a little bit better that there's actually stuff happening. So that was just now. Let's quickly give it something. And because Stripe is nice, they have this amazing credit card number, which just works. So in case you ever want to buy something, that credit card number works perfectly fine. I don't know if somebody will be sad or mad about that, but it works, and I can pay with that. And we see some things happening here. So I get the charge succeeded event from Stripe. I generate a couple of things in the database, like an invoice, an order, and the order events. There's my SMS. It worked. Live demos. So the way it works is the CDC tool looked at the order table, saw, okay, there's a new order, so I need to act on that. I need to generate the event, the invoice. I need to send out the notification and stuff like that, right? And for the sake of time, let's go back real quick. So that was not a massive demo, but it shows that you can actually build things like that, like pipelines like that, without much effort. What I wanted to do is build all of that in like no or low code implementations. So my tool is not built specifically for that use case, so it was just configuration. N8N is a low code or no code workflow engine. Buddybase is a low code UI framework. That was set up. I don't recommend anyone trying that at home. That was not a pleasant experience. And my phone just, it was an Android phone, right? So you can build pretty complex things with that without actually really coding anything, just putting things together, ready to use plugins. So we're coming back to that, and I said there is a couple of pipelines. So for us, it was all Kafka. I said Kafka is not necessarily the best implementation, and eventually we switched to Nuts for the new services. So we figured that out as well. So the ingress pipeline for us is we could use a lot of different devices. And all those device manufacturers, they're really mean because they cannot agree on a single data protocol. That's a really sad world. So what we had is we had a lot of different decoders trying to understand the different data protocols, trying to bring them all to a standard subset or a standard implementation. So it was basically a whole lot of stuff that just sent the same messages over and over, trying to decode them, eventually send them somewhere else, right? So we have the ingress queue and Kafka. Then we had the data pipeline, which which waited for some specific events. So for example, we have the heat index calculator, and heat index in the world of animals is a specific value built out of temperature and humidity and gives you an index value like how dangerous for specifically cows and horses is that level of humidity temperature. Basically, like what is the felt temperature? And the higher the humidity, we all know that, right? For animals, that can be actually as dangerous as death. So what we did is we had this calculator set up to say, okay, when I receive temperature and humidity from the same device, I want to generate a new, now virtual measurement, which does not actually exist, and we send that back to the same pipeline. And in theory, you could have another thing here, which now waits for the heat index, right? So again, you had this like massive cycle of things where elements could just react on each other. Then we had the event pipeline. That thing generated like most of the general events, like, hey, we've seen something specific from a device, or there was no message from a device in like 5 minutes, stuff like that, generating additional events. And you send those around, and sometimes you want to do something, right? So the device didn't send anything for an hour, or the RSSI, like the what is it? The reception value or the reception quality is really bad. You may want to alert the user and say, hey, maybe move that device somewhere else, or unplug it, restart it, something like that, right? For them, it was like, are my animals safe? Are they healthy? Are they secure? And that means you want to make sure that those things are available. But it included a lot of different things. Most of those services were implemented as simple data pipelines or as CQRS, right? Where you basically had certain things, you wrote them to the database, and that all worked. And then there's like the webhook pipeline, we can ignore that. That basically just had the option to send it to some partners that did additional elements. But there's one important thing about that, and that is where all this goes to. You remember I said resiliency and maintainability. That was just barely maintainable. It worked, and it worked great. It was super scalable because we basically had so many services that we could scale every single piece individually. Would I recommend anyone doing that? Not necessarily, right? Really make sure that you only do the absolutely necessary. For us, that was like the third or fourth re-implementation of the whole system. So we kind of knew where we went to, and most of the time it was like a full rewrite. And every single time we hit a barrier like, okay, that doesn't work for us anymore, so now we need to do the next thing, right? We need to get to the next level. Eventually, that thing, this whole ingress pipeline, was JavaScript, because we needed to add new devices in minutes and hours instead of days. So we didn't even want to recompile. You just wrote something in TypeScript, you send it to the database, it was automatically reloaded, precompiled into JavaScript, dropped into a sandbox in Node.js, and it ran. That was not my initial thought when I built that, but it is what we ended up with. Anyway, so as I said, it's always the trade-off between complexity, scalability, and resiliency, and responsiveness, right? So keep in mind there is trade-offs, and only do it when you really have to. And there is a minute or two for questions. Sorry, I know it was a lot of stuff. Questions? I think there you go.
I once had to write a paper about what scenarios you could apply Kafka, RabbitMQ, etc. And one big problem was to find find a term to collect all those engines together so that you don't lose one thing, and then the neighbor ended up trying to find a term for all those things. You somehow call it message brokers, but somehow, to me, when I wrote that was not the right term. And I in the end called it real-time data processing engines. But we have a better term that would be really interesting.
Right. So what he said is he wrote a paper about Kafka and ActiveMQ and RabbitMQ and tried to find a general term for all of those things, like message broker. You said you ended up with a real-time data processing engine. And if I have a better term, no. No, I don't. As I said, naming things is hard. There was a lot of terms that are already used interchangeably. I prefer to call those things in general data pipeline. The second you have like a source, a sink, and something in between, I think data pipeline is like the best term. But a real-time engine may be a perfect term. It depends on the implementation, because some of those implementations are not actually real-time. They do micro batches, which is like small batches, but they're still batching. Hazelcast Jet is one of those examples that does micro batches. So it all comes down to be like, yeah, is it a microservice? Is it SOAP? Is it whatever you want to call it, right? Naming things is hard. So no, sorry, don't have a better term for that. One more question, maybe? Otherwise, thank you very much.